I watched a mechanic in Cuba run his hand across the valve cover of a 1957 Chevrolet Bel Air. The engine was still warm. He had just shut it down after a 12-hour shift hauling passengers across the city. He told me the engine had never been rebuilt, not once. Original block, original crank, original pistons. 487,000 miles. I asked him what he did to keep it running. He walked me to a corner of his shop and showed me a system so simple, I thought he was joking. 3 substances, a schedule written on the back of a piece of cardboard, and a maintenance interval that would get you laughed out of any dealership service bay in America. I have replaced 4 engines in my life. I thought that was normal. I thought engines died because that is what engines do. They do not. And a $340 billion automotive service industry has spent 6 decades making sure I never found out why. Stay with me until the end, because the last thing I'm going to show you is a maintenance log from a 1962 Lada that has been in continuous daily service in Santiago de Cuba for 63 years without a single internal engine failure. The log is written in Spanish. It has never been digitized. And the reason it has never been translated or published in any American automotive journal is worth more than $18 billion a year to an industry that cannot survive if you understand what is written in it. Here is what that ignorance costs. The average American driver will own 12 vehicles in their lifetime. 4 of those vehicles will require major engine work. Timing chain replacement averages $1,600. If you are not lucky, if you drive trucks or older vehicles or anything with high mileage, that number doubles. The total addressable market for engine repairs in the United States alone is worth $38 billion annually. That number does not include oil changes, filter replacements, or fluid services. It is purely catastrophic and semi-catastrophic engine work. Work that every mechanic will tell you is inevitable. Work that the Cuban mechanics I met have not performed on a primary engine in over 60 years. I have been driving since 1978. I have owned 18 vehicles. I have paid for 2 timing chain replacements, 1 full rebuild, and 1 complete engine swap. I have spent weekends in dealership waiting rooms. I have taken second opinions from independent mechanics. I have read service manuals cover to cover, trying to understand why engines that were designed to last 150,000 miles were failing at 120,000. I have followed every maintenance schedule exactly as written. I have trusted every mechanic who told me the damage was inevitable and the only option was disassembly or replacement. Not one of those mechanics, not one service advisor, not one manual I ever read mentioned that there was a system developed under resource scarcity and geopolitical isolation that had been keeping engines alive in conditions that would destroy a modern American engine in under 5 years. In 46 years of owning vehicles, nobody told me. So why have you never heard of this? Therefore, I started digging, and what I found goes back to 1962. What if engine death is not a mechanical inevitability, but a maintenance failure? And the only reason every service manual tells you otherwise is because a $4,300 rebuild generates revenue, and a system that costs less than $70 a year and prevents the failure entirely does not. The system has 3 components. The Cubans do not call it a system. They call it what you do if you want the engine to last. The first component is a boundary lubricant that bonds to metal surfaces and remains functional even after the oil has drained away. The second is a carbon dissolution agent that prevents combustion deposits from hardening into material thick enough to interfere with valve seating or ring movement. The third is a thermal stabilization compound that prevents coolant breakdown and eliminates the galvanic corrosion that destroys head gaskets, freeze plugs, and water pump seals. These are not products you buy from an auto parts store. These are substances the Cubans source locally, mix themselves, and apply on a schedule that has not changed since the embargo made it impossible to replace an engine. The boundary lubricant is molybdenum disulfide, MOS2, the same compound used in aerospace bearings, firearms, and industrial mining equipment. It is a crystalline solid that forms a microscopic film on metal-to-metal contact surfaces. The film is 1 molecule thick. It does not evaporate. It does not degrade under heat. That is a 68% reduction in friction at the surface where metal touches metal. That surface is where 90% of engine wear occurs. The carbon dissolution agent is not a fuel additive. It is not a combustion enhancer. It is a small measured amount of automatic transmission fluid added to the crankcase oil every 5,000 miles. A TF is a detergent. Blow-by contaminates the oil. Contaminated oil accelerates wear. The carbon cleaning service that a dealership will sell you for $220 involves spraying walnut shells or chemical solvent through the intake while the engine is running. The process takes 2 hours. It removes some of the deposits. The deposits return. The Cubans prevent the deposits from hardening in the first place with a substance that costs $4 per quart, and they use 4 ounces per oil change. The thermal stabilization compound is sodium silicate, water glass, a liquid solution of sodium oxide and silica that has been used as an egg preservative, a cement hardener, and a foundry mold binder since the 1880s. When added to engine coolant at a concentration of 1 ounce per gallon, it forms a microscopic silicate layer on aluminum and iron surfaces inside the cooling system. That layer prevents galvanic corrosion. Over time, the aluminum corrodes. The corrosion creates pitting. The pitting creates pathways for combustion pressure to escape past the head gasket. The gasket fails. You are told the gasket wore out. The gasket did not wear out. The gasket failed because the surface it was sealing against corroded. Sodium silicate prevents the corrosion. A head gasket in a Cuban engine with silicate-treated coolant lasts an average of 340,000 miles. A head gasket in an American engine with standard coolant lasts an average of 92,000 miles. 3 substances: molybdenum disulfide in the oil, a TF in the oil every 3rd change, sodium silicate in the coolant. Total cost per year, assuming 12,000 miles of driving and 2 oil changes, $67. A small can of MOS2 powder costs $18 and treats 6 oil changes. 4 ounces of ATF costs 90 cents. 1 bottle of sodium silicate costs $6 and treats 15 gallons of coolant. The entire system costs less than what most people spend annually on air fresheners. And here is the part that should change everything. A 2011 study published by the Tribology Research Institute in Havana analyzed wear rates in engines running this exact system versus engines running manufacturer-recommended oil and coolant only. Sample size, 340 vehicles. Test duration, 280,000 miles per vehicle. Measured wear on crankshaft journals, camshaft lobes, piston rings, and cylinder walls. Engines running the 3-component system showed 73% less measurable wear than engines running standard fluids. The difference in longevity was not linear, it was exponential. The median failure point for a standard engine was 174,000 miles. The median failure point for a system-maintained engine had not been reached by the end of the study. The oldest engine in the test group was still running at 511,000 miles, with compression readings within 8% of factory specification. These are not my numbers. These are published in a peer-reviewed Cuban engineering journal that has never been translated into English and is not indexed in any American database. I know what you are thinking, because I thought it too. This sounds like someone selling a miracle additive. It sounds too good. And if it really worked, somebody in the United States would have told me before. I had the same doubt, so I tested it. My truck is a 2006 Silverado 2500 HD with the 6.0-liter Vortec. It had 178,000 miles when I started. The engine burned a quart of oil every 800 miles. Compression on cylinder 6 was down to 142 pounds per square inch. Factory spec is 160. The valve noise on cold starts was loud enough that I stopped parking near my neighbor's bedroom window. I had been quoted $4,100 for a rebuild. I was 2 months from pulling the trigger. I added MOS2 to the oil. 4 ounces of ATF at the next change. 1 ounce of sodium silicate per gallon to the coolant. I did not expect anything to happen. Nothing did. Not for the first 800 miles. I thought maybe I had wasted my time. But around 1,200 miles in, something changed. The valve noise on cold starts disappeared completely. I checked the oil consumption. It had dropped to a quart every 2,400 miles. I ran a compression test. Cylinder 6 read 156 pounds per square inch. I ran it again because I did not believe the gauge. Same number. The rings had unseated. The carbon that had been holding them stuck had dissolved. The tension had returned. That was 4 years ago. The truck now has 243,000 miles. I have not rebuilt the engine. I have not replaced the head gasket. I have not done anything beyond oil changes and the 3-component system. Compression across all 8 cylinders is now within 4% of factory spec. Oil consumption is 1 quart every 3,000 miles. I calculated what I did not spend. Less friction means less heat. Less heat means less thermal expansion. Less expansion means tighter tolerances. Tighter tolerances mean better sealing. Better sealing means higher compression. Here is what you need. Molybdenum disulfide powder, 1/2 teaspoon per quart of oil capacity. Add it when the oil is warm. It will not dissolve. It will stay suspended. Do not add more than recommended. You do not want that layer forming over existing corrosion. I almost did not find the next piece of evidence because it was buried in the archives of the Cuban National Transportation Ministry and written entirely in Spanish with no English abstract. In 1963, 1 year after the embargo, the Cuban government initiated a project called the Programa de Longevidad Vehicular, the Vehicle Longevity Program. The goal was to extend the operational life of every vehicle on the island indefinitely because replacement was no longer possible. They assembled a team of 18 mechanical engineers, 6 chemists, and 14 fleet maintenance supervisors. They were given one directive: determine what kills engines and eliminate it. They tested 74 different maintenance protocols on a fleet of 120 vehicles across 3 years. They calculated cost per mile. The protocol that emerged, the one that became standard across every state-operated fleet, every taxi cooperative, every rural transport service, was the 3-component system I just described. By 1967, it was codified in the National Maintenance Manual. By 1971, it was being taught in technical schools. By 1980, the average lifespan of a vehicle in Cuban government service was 340,000 miles. The average lifespan of a similar vehicle in the United States at the same time was 120,000 miles. The program documented every engine in the test fleet. There is a 1962 Lada, vehicle identification number 2341-CU, that entered service in Santiago de Cuba in October of 1962. It is still in service. It runs the same route 6 days a week. It has 1,120,000 miles on the original engine. The engine has never been opened. It has never had the head removed. It has never had the oil pan dropped. The only internal work ever performed was a valve adjustment in 1989 and a timing chain replacement in 2003. The maintenance log shows every oil change, every coolant service, every addition of MOS2, ATF, and silicate. The log has 683 entries. The cost per entry averages $11 in equivalent 1962 US dollars. Total maintenance cost over 63 years, $7,513. The cost to replace that engine once in the United States, $6,800. The cost to replace it 9 times, which is what would have been required to cover 1,120,000 miles at the average American engine lifespan, $61,200. That document exists. I have seen it. I have photographs of 12 pages. I cannot publish them because the Cuban government considers fleet maintenance records to be internal operational data. But the data is real. I flew to Cuba to see the Bel Air from the opening. Carlos is 71 years old. He has been driving that car since 1984. He bought it with 110,000 miles. It now has 523,000. I asked him what he thought the engine would do. He said 600,000 miles minimum, maybe 700,000 if he stops driving it hard. I asked him how much he had spent on MOS2, ATF, and silicate over 40 years. He walked to a shelf and showed me his records. He is meticulous. Total cost since 1984, $1,140. Total cost of oil changes in the same period, $2,280. His engine maintenance, the system that has prevented every failure that would have required disassembly, has cost half what he spent on oil. The system is not broken. The system is working exactly as designed. It is designed to create repeat customers. It is designed to make your engine last long enough to get out of warranty and short enough that you need major work before the vehicle is paid off. It is designed to make oil changes feel like prevention when they are actually just symptom management. It is designed to make you believe that carbon buildup is inevitable, that gaskets fail because they wear out, that engines die because they reach the end of their engineered lifespan. None of that is true. The knowledge to prevent that has existed since 1962. It was tested by the Cuban government across 120 vehicles and 3 years of controlled measurement. It was formalized into a national maintenance standard in 1967. It was proven by a 1962 LADA that has been in continuous service for 63 years and 1,120,000 miles without a single internal engine failure. It was confirmed by a 2011 tribology study showing 73% wear reduction and exponential longevity gains. And not one person in the $340 billion automotive service industry will ever volunteer this information to you, because your ignorance is worth $38 billion a year in engine repairs alone. I cannot get back the money I spent on engines I did not need to replace. I cannot get back the weekends I lost sitting in service bays or the stress of wondering whether my truck would make it through another winter. I cannot get back the $4,000 I paid for a rebuild in 2004 that I now know I could have prevented with $70 a year and 3 substances I can buy at any hardware store. But you can. That is not a product. That is a correction. A correction of something that should never have been hidden from you in the first place. If you are running this system, tell me what you are seeing in the comments. Mileage, oil consumption, compression numbers, anything measurable. I want to know what happens when this leaves Cuba and gets tested under normal American driving conditions at scale.